of mechanics, which is called as the dynamics part, is of main interest because now the bodies, those rigid bodies, particles, they will start moving. Now here we can deal with several objects, and those objects, they will be moving either relative to each other or with respect to ground. Those particles, they will be thrown up the ground or they will be moving towards the ground. There could be some trajectory that will be followed by these objects, and we are required to judge the velocity as well as acceleration of these bodies at every time. Also that there will be several bodies which will be hitting each other, called as the impact, and then after the impact those bodies will be moving in some other directions with some different velocities, and we are required to calculate as what is the velocity after the impact and whether there is some energy loss in that particular impact or not. When we talk about the impact, there could be some coefficient of restitution, because we will be learning the impact of the two bodies, and when the two bodies hit each other, then the velocity change will take place, and then you will find that the law of conservation of momentum is still followed, but the velocities are not retained, or you are not going to regain the same velocity or same energy that was present with the bodies before the impact. Now all these criteria are to be thought of, and in dynamics we are going to have the closer look at all of these. Now initially, if we read some problems like, say a ball is thrown up from the top of the building, say whose height is 40 meters. Just listen to the problem carefully. There is a building whose height is 40 meters and some object, some stone or some ball is thrown up, say with velocity 10 meters per second. And we are required to find out as in how much time it will be hitting the ground, number one. Number two, what was the maximum velocity or velocity with which it will hit the ground. Number three, it could be what is the maximum height that is attained by that particular object. Now can you imagine first of all this situation? What is happening is some stone is thrown up from the building, from the top of the building, whose height is 40 meters. Now if the stone is thrown up, first of all what we are given is the initial velocity of that particular stone, which is 10 meters per second. And the question is, we are at this juncture aware of some fundamental equations of velocity, of motion, which are the Newton's laws of motion. The first one being S is equal to ut plus half at square, where S is nothing but the displacement, u is the initial velocity, t is the time after which you want to calculate the displacement. That means the initial velocity is treated as time t equal to 0, and we will be finding the displacement s at the given time. So you can substitute value of t, plus 1/2 at square, where a is the acceleration and t is again the same time. Now the concept of acceleration is known to you. Acceleration is responsible for the change in the velocity. Rather, we will be increasing, the velocity will be increasing if the acceleration is positive. Now there is also a term like over a period of time the velocity will be decreasing. In that case we will be calling it as the retardation. That means the acceleration will be negative. Now whether the acceleration is positive or acceleration is negative, the displacement is bound to take place. Now there are even cases when the acceleration is 0. Now when we look at this particular problem and the stone is thrown upward with the velocity of 10 meters per second, the question is whether it is acted upon by any acceleration, and the answer is obviously yes, because whenever we are talking about the ground, the gravitational acceleration will always come into picture, and that gravitational acceleration is the one which is responsible for attracting all the bodies towards the ground. Now as the body is attracted towards the ground, there is a pulling force which is exerted by the earth, and that acceleration is what we call it as the gravitational acceleration g, whose value is roughly 9.81 meters per second square. So whenever we talk of the free fall, whenever we talk of the free traversal in the air, then we will have to take into account the gravitational acceleration in the vertical direction. It is vertically downward. Now it doesn't mean that other accelerations will not be present, but those should be explicitly mentioned.